Okay, hello. I would like to do a few more problems where we're dealing with the difference of squares and the difference in sum of cube formulas. So on our factoring flow diagram, here's that sheet again, I want to do a few problems that are going to use these three formulas. So let's take a look. Let's start with a problem like this. X squared minus 100. And if the directions just say to factor, then what I'm thinking about is I'm always starting with, is there a greatest common factor? And if there is, we factor it out. There isn't in this problem. You'll notice there's no greatest common factor. So then we're going down. How many terms are there? There's two terms. We want to see if we can make it fit one of these forms right here. Okay? Excuse me. So what you'll notice is I can actually write this number 100 as a square, because I can write it as x squared minus 10 squared. 10 squared is the same thing as 100. So what I've done is I've actually made it fit this form right here, this a squared minus b squared form. Okay. The nice thing about that is when I can get it to fit this form, then I can actually factor it using the formula into a minus b and a plus b. Okay, so if I notice that the a is equivalent to my x in the formula, and b is equivalent to my 10, that's because if I take a look at what's actually being squared here, the x is being squared, the 10 is being squared, and those equate to the a and the b in the formula. Okay. So if I then just take these two, and everywhere, the x and the 10, and everywhere there's an a and a b in my formula, if I just plug in x and 10, then I'm using that formula to factor this. Okay, so it's going to look like the a minus the b, which is x minus 10, times the a plus the b, which is actually x plus 10. Okay, so that would be factoring using the difference of squares formula. Let's take a look at one of the cube formulas. Let's do something relatively easy to start with. Something like x cubed plus 8. Again, the directions are to factor. Okay, so you'll notice that this one does not fit this difference of squares formula, right? First of all, difference of squares, you have to have a minus sign, and you need things to be in the form of something squared, and that's not this. This is, we have an x cubed here. So we're thinking, can I make it fit one of these cube formulas? And obviously we would need to try and make it fit the sum formula because we're looking at having a plus sign in the middle there. So I want to think about, is there any way that I can write this 8 as something cubed? Well, yes, I can. I can write it as a 2 cubed. Okay, so now it fits that form because, I'll just leave it right there, because I notice that the a is equivalent to the x, and in other words, what's being cubed in this formula is the x, and what's being cubed in this right here for the second part there is a 2. Okay, so wherever there's an a, I'm going to replace it with x. Wherever there's a b, I'm going to replace it with a 2. And we're just going to stick it into this formula right here. I don't know if you can see that formula real well. Let's bring it up here. A plus b, a squared minus ab, and plus b squared. Okay, so if we plug those in, it's going to look like x plus 2, that's the a plus the b, times a squared, which is x squared, minus the a times the b, which is going to be 2x. That's actually b times a, but a times b times a are the same thing. And then plus the b squared there. Okay, so b is actually a 2. And I'm squaring that. So on the next line, I'm actually going to write this out. That 2 squared I'm going to write out as a 4. So this becomes x plus 2 times x squared minus 2x and then plus the 4. Okay, so that's that factorization. These trinomials will never factor further. When you're using these cube formulas, the trinomial part doesn't factor further. Sometimes these ones, the binomials, will factor further. You'll have to check and see if they fit a difference of squares form. But in this problem, that's done. Okay? All right, Let's try something that's a little bit bigger. Let's see. Let's try this problem right here. Let's try 27. 27x cubed minus 125 y cubed. And directions again are just a factor. Okay, so if we're using our factoring flow diagram and we're asking ourselves, is there a greatest common factor? And if we take a look at this, 27 and 125 don't share anything, so no GCF there. We go down, we take a look at two terms. Can we make it fit any of these forms? And yes, we can, because we can write both 27 and 125 as cubes. So what I'm going to do is do that, write it in the form of the cubes. 27 is 3 cubed times x cubed, and then this is minus 5 cubed times y cubed. Okay, and I want to see what it is, the entire thing that's being cubed in each of these pieces, so I'm going to rewrite this as 3x as a quantity cubed. Again, I'm just using a rule from chapter 4 in reverse. This rule says that, you know, if I have two things that are multiplied taken to a power, then each of these things are taken to that power. I've actually used that to write this as a quantity cube because I want to be able to identify my A and my B in the formula. So this is also 5y quantity cubed. Okay, so my formula says, and let's bring it up close here, a cubed minus b cubed factors into a minus b, a squared plus ab plus b squared. Okay, so I want to identify my a. My a is 3x, and my b is 5y. So again, everywhere there's an a, I'm going to plug in 3x. Everywhere there's a b, I'm going to plug in 5y. So let's see if we bring that right. And you can't see that, so I'm going to write it out bigger. A cubed minus b cubed. The formula factors into a minus b, and a squared plus ab plus b squared. Okay? All right, so let's plug it in. We've got 3x and then minus 5y. That's the a minus the b. And then we've got a squared. Well, notice that a has two things in it. Okay, so I need to square both of those things. I'll do that on the next line. And then we're going to have plus 3x times 5y. That's plus a times b. And then plus b squared, 5y squared. Okay, on the next line, let's simplify that. 3x minus 5y. The 3 is being squared, and so is the x. So that's going to become 9x squared. 15xy, and then 5 squared is 25, and then y squared. And that's it. Running out of time, so I'm doing that a little fast, and I'm going to stop it now. Oops, can't see that. Okay, 9x squared, 15xy, and then 25y squared. They make me keep these videos to 10 minutes, so I don't want to go over. Okay.